Ragdolls in S&box. What does your code see and what can we learn from it? First off, you can set up a ragdoll through ModelDoc, but that's not the end of it. You can still mess around with them in your game. That's because ragdolls are just a physics group, which is a collection of physics bodies and physics joints, which connect the bodies together. The collisions of a physics body is made out of physics shapes, which are geometric shapes such as cubes and spheres. This is because if we were to use mesh collisions, then kiss your FPS bye-bye. The math calculations for basic shapes is much faster. That's why when you inspect a ragdoll's collisions, you see it's made out of shapes, mostly cylinders. Now to connect the physics bodies of the ragdoll, we have physics joints. Ragdolls will probably only use a type of joint called hinge. That's the one where you can define how much a limb can rotate, or else you'll end up with a boneless mess of a body. Speaking of bones, what we talked about was just the collisions, which is what the server sees. Now let's move on to the model, which is what the client sees. The model is made out of bones. Each bone has a transform struct, which dictates its position, rotation and scale. Without bones, you'd only have a T-posing model. Move the bones around and you can pose the ragdoll. When a ragdoll is created, the bones are paired up with their corresponding physics body. This is, again, set up through ModelDoc. We might do a tutorial on that later. Now let's get to the programming part. I have loaded up the S&box game, but really you can do this anywhere. We'll start off with a classic from Gmod, freezing a player. I've already gone ahead and created a new class called statue, which derives from model entity, just like a ragdoll. You can do this with just a console command, but you will see later on why it's useful to have it in its own class. Let's add a static method which takes your S&box player. And let's quickly steal S&box's code for making a ragdoll similar to the player. Let's patch these holes by putting our player variable. And instead of making a model entity, let's make our statue. Let's also make a console command to test it out. We'll explain console command in another fish bite, but with this, we first get the pawn of whoever is calling the command, then cast the pawn as a S&box player. Then we call our static method, and then we respawn the player. Let's hop in game and try the command out. You can see it autofills when we type statue. Oh, how embarrassing. It doesn't have any pants. That's because my character is wearing clothing which disables the legs body group. Let's just comment out the body group's line and try it again. You would keep it if you wanted to dress the ragdoll up. Now look at them though, flopping around. Let's get to the freezing part. Back in Garry's mod, you would have to loop through all of the bones, then nest another loop and weld them all together. However, in S&box, you can do this with just 2 lines of code. For each joint in the entity's physics group, get all of the joints, create a new joint between point 1 and point 2. This is going to loop through all of the physics joints inside of the ragdoll's physics group and then makes a similar fixed joint. A fixed joint is basically a weld from Gmod. It will try to keep the 2 limbs together. The joints point 1 and point 2 are just physics points, very creative naming scheme by the way, which define which physics bodies are connected and where they are connected. Let's try it out in game, and look at that, frozen solid with just 2 lines of code. Now this is the Garry's mod way of freezing a ragdoll. You can see that if you push it, it still bends. Instead of being frozen, you could say it's stiff. And for some reason, I'm guessing it's because of how it's been set up in ModelDoc, they make this pose every time. So let's look at the S&box way of freezing a ragdoll. Completely frozen solid. Instead of multiple physics bodies, which are connected by physics joints, we'll have a single physics body with multiple physics shapes added on top of it. Let's start by setting stuff up. Something I believe is lacking in the Bonds API is the ability of reassigning the physics body they've been assigned to. So we'll need to keep the old ones around, since we're gonna have to manually update their transforms after we disable their physics. So let's keep tab of each of the Bonds transforms with a dictionary. In the API, bonds are represented by an integer. A new dictionary with an integer as a key, aka the bond, and a transform as a value, aka the position and the rotation they've been frozen into. Let's delete this old code. Let's loop through all of the physics bodies inside of the ragdolls physics group. And now let's just ignore the current physics body we're looping through if it's the parent physics body. This is where we'll add all of our other shapes anyway. Now loop through all of the physics shapes inside of the physics body and add all of them to the parent's physics body. Add clone shape is useful because it handles everything for you, even setting the position and rotation. Get the bond that's been assigned to that physics body, which I remind you is an integer, so in our case bond number 1, bond number 2, etc. And now, for the bonds transform, and let's get the transform relative to the ragdolls transform. This means that in a 3D coordinate system, the ragdoll is always going to be the center of it. We're doing this so that it handles the offset and rotations for us. We just have to tell it how to interpret it. Are we feeding it a transform that is relative to the world or to the ragdoll? We can use the main physics body own transform to call a method which takes the bond's current transform and returns one relative to the ragdolls. Now let's just add this bond and its local transform to the dictionary. Clear the shapes of the physics body we're looping through since we already made a copy of it, and then disable it so it doesn't go flopping around on us. Like I mentioned before, we're gonna have to manually set the bonds transform, because if we were to turn into a statue now, you can see it's just standing there, with the exception of the root bond, which we skipped since it's assigned to the main physics body. But if you enable the server wire physics debug, you can see that the shapes are all there. Let's go back to the code and finish this up. Create a new method which runs every tick and loop through every item in our dictionary. Do the opposite of what we did before. This time we want the bonds transform relative to the world, not the ragdoll. You can see earlier that we used toLocal, and now we are using toWorld. So if the statue has moved, then we can get the bond's updated position and rotation. Set the bonds transform. Bond key, I remind you, is the integer we stored, which represents the number of the bond. And now let's try it out. We finally have a statue, frozen solid. You can pick it up with your grav gun and do whatever you want with it. Now, as a challenge, I'd like to see you put clothes on top of the statue, the same ones that the player is currently wearing. If you followed Fish School, you could probably do it without a problem. Very easy, very shrimpable.